Everyone has heard of the Big Bang Theory, but relatively few people have an accurate understanding of what it is about. There are all sorts of claims out there on the internet people make about the Big Bang Theory that simply aren't true. So, in this video, I'm going to introduce the theory properly and try and clear up some common misconceptions. The Big Bang Theory is an explanation for how the universe we see around us today came to be in its current form. One of the most remarkable discoveries of the 20th century was that our universe has not always existed in the state in which we observe it today. If you rewound the cosmic clock back far enough, you'd find that the universe appeared very differently. There won't be familiar structures like stars and galaxies anymore, but a high-energy primordial soup of fundamental particles. This is what the Big Bang Theory tells us, that around 13 billion years ago, the observable universe that we see around us today occupied a space smaller than whatever room you happen to be sitting in right now, and that since then, it's been expanding to its current size. We believe that this is the case, not because we like this theory more than any other, or because of any philosophical predispositions, but because a vast quantity of cosmological data and the various features of the cosmos today can be predicted and explained extremely well by the theory. It is in this sense that the Big Bang Theory can be called the theory of our cosmic origins. It explains so many of our observations of the present universe and where they come from. Many people, however, misinterpret the Big Bang as a theory of ultimate origins. They seem to think that it is a theory about the origin of everything, of all reality, that it is an explanation for why there is something rather than nothing, or that it explains how something can pop into existence from nothing. This is not what the Big Bang Theory is about. All the Big Bang Theory tells us is how we get today's universe from an initial hot, dense, primordial soup of fundamental particles. It isn't a claim that the universe comes from nothing, or that it was the result of two primordial atoms colliding, or that it was an explosion of nothing. It merely explains how the expansion of a pre-existing physical system, the primordial soup, becomes our universe that we see today 13 billion years down the line. This is an incredibly impressive feat, but it isn't an ultimate, complete explanation for the origin of all reality. Of course, the question everyone wants answered then is, where does this initial state come from? Well, that's the big question. We're working on an answer to it, but at the moment, no currently accepted physical theories are capable of providing one. You see, for the vast majority of the history of our universe, our current physical theories are good enough to explain how everything works. But once we get to this stage, the primordial soup, that is no longer the case. The energies beyond this point in the past are too high for our physical theories to cope with, and so nothing sensible can be said beyond this point. Now, you may hear some people call what comes just before the primordial soup a singularity, but this can cause a lot of confusion. A singularity is not some kind of infinitely dense, infinitely small, mysterious physical object. A singularity is a region in the mathematical description of our physical theories in which the theory itself breaks down. A singularity is a problem with our mathematical descriptions of reality, not a physically existing object itself. So when physicists talk about the Big Bang singularity, they don't really mean the actual first moment of all reality, but simply the first moment at which our physical theories start to work. So this dense primordial soup that the Big Bang Theory begins with is not the actual initial state of all reality, or the first thing that ever existed. It is just the first moment at which our physical theories work and can then be used to predict the future evolution of the universe up until today. The Big Bang Theory is an incredibly accurate and profound explanation of how our universe today developed from this primordial soup. But it is not a theory of ultimate origins. To understand how this primordial soup got there, we need more sophisticated theories of physics, such as a theory of quantum gravity. This would allow us to peer back even further into the past. For now, what came before the primordial soup is anyone's guess, and there are all sorts of bizarre yet well-motivated ideas. Perhaps our universe is just one of many in a larger multiverse. Or perhaps, in the past, time and space themselves break down into something more fundamental. Perhaps there is a mirror universe which extends before the beginning of our own. Or perhaps our universe exists inside a black hole of another universe. All of these are legitimate possibilities as far as we know, but the truth will depend on whatever the correct quantum theory of gravity turns out to be. Of course, one could also posit that some omnipotent deity created the primordial soup out of nothing, and that's how it came about. But this is quite unsatisfying and ad hoc on multiple levels. How can something be created from nothing? Why start with the primordial soup and not the state of the universe as it is today? One also encounters the fiendishly difficult problem of explaining how supernatural and natural systems can interact with one another. There's certainly nothing stopping someone from saying, God put the primordial soup there, but seeing as we can explain virtually the entire 13 billion year history of our universe without appealing to anything beyond natural physical laws and processes, why change tactics suddenly at the frontiers of current understanding? To conclude then, the Big Bang Theory is an explanation for how our universe today developed from the earliest state at which our physical theories still work. We don't know where this early state comes from, but it is a fascinating question, and the most promising way to address it is surely by developing more sophisticated, more fundamental descriptions of the natural world.